blog post, The 50-Year Quest, My Personal Journey. Good title. My Personal Journey with the Second Law of Thermodynamics. So what is this law, and what have you understood about it in the 50-year journey you had with it?
Right. So Second Law of Thermodynamics, sometimes called Law of Entropy Increase, is this principle of physics that says, well, my version of it would be things tend to get more random over time. Mm-hmm. A version of it that there are many different sort of formulations of it that are things like heat doesn't spontaneously go from a hotter body to a colder one. When you have mechanical work kind of gets dissipated into heat. You have friction and kind of when you systematically move things, eventually there'll be sort of the energy of moving things gets kind of ground down into heat. Mm-hmm. So people first sort of paid attention to this back in the 1820s when steam engines were a big thing. Mm-hmm. And the big question was, how efficient could a steam engine be? And there's this chap called Sadi Carnot, who was a French engineer. Actually, his father was a sort of elaborate mathematical engineer in France. But he figured out this kind of rules for how kind of the efficiency of the possible efficiency of something like a steam engine. And in sort of a side part of what he did was this idea that mechanical energy tends to get dissipated as heat. Mm-hmm. That you end up going from sort of systematic mechanical motion to this kind of random thing. Well, at that time, nobody knew what heat was. At that time, people thought that heat was a fluid, like they called it caloric. And it was a fluid that kind of was absorbed into substances. And when one hot thing would transfer heat to a colder thing, that this fluid would flow from the hot thing to the colder thing. But anyway, then by the 1860s, people had kind of come up with this idea that systematic energy tends to degrade into kind of random heat that that could then not be easily turned back into systematic mechanical energy. Mm-hmm. And then that quickly became sort of a global principle about how things work. Question is, why does it happen that way? So, let's say you have a bunch of molecules in a box and these molecules are arranged in a very nice sort of flotilla of molecules in one corner of the box. And then what you typically observe is that after a while, these molecules will be kind of randomly arranged in the box. Question is, why does that happen? And people for a long, long time tried to figure out, is there, from the laws of mechanics that determine how these molecules, let's say these molecules are like hard spheres bouncing off each other, from the laws of mechanics that describe those molecules, can we explain why it tends to be the case that we see things that are orderly sort of degrade into disorder? Yeah. We tend to see things that, you scramble an egg. You take something that's quite ordered and you disorder it, so to speak. That's a thing that sort of happens quite regularly. Or you put some ink into water and it will eventually spread out and fill up, fill up the water. But you don't see those little particles of ink in the water all spontaneously kind of arrange themselves into a big blob, mm-hmm. and then, jump out of the water or something. So the question is, why do things happen in this kind of irreversible way where you go from order to disorder? Why does it happen that way? And so throughout, in the later part of the 1800s, a lot of work was done on trying to figure out, can one derive this principle, this second law of thermodynamics, this law about the dynamics of heat, so to speak, can one derive this from some fundamental principles of mechanics? In the laws of thermodynamics, the first law is basically the law of energy conservation, that the total energy associated with heat plus the total energy associated with mechanical kinds of things plus other kinds of energy, that total is constant. And that became a pretty well understood principle. But the second law of thermodynamics was always mysterious. Like, why does it work this way? Can it be derived from underlying mechanical laws? Mm-hmm.